Refraction through lenses. There are two kinds of lenses. There is a convex lens that is also known as a converging lens, and there is a concave that is known as a diverging lens. Lenses are pieces of glass, hence they are known as optical medium. If you look at the diagrams on the left hand side, these two lenses on the top and the bottom are convex lenses. These two lenses on the right hand side are concave lenses. Coming first to the left hand side bottom diagram, there is a convex lens. The line passing through the center of the lens is known as its principal axis. So if I draw the principal axis, this line is known as the principal axis of the lens. The point exactly in the center of the lens is known as its optical center. If we consider rays coming from infinity, for example, rays coming from sun, after hitting the lens, they undergo refraction. Since lens is a transparent material, the refraction takes place. After passing through the convex lens, these rays of light meet at a point on the right hand side. This point F2, where these rays are meeting, is known as the principal focus of the lens. Now, since there is a possibility that the rays might be coming from left hand side as well as from the right hand side, every lens has two principal foci. The one on the right hand side for the convex lens is known as the second principal focus F2 as shown in the bottom diagram, while the one on the left is known as F1, that is the first principal focus. Conversely, look into the diagram at the top. The rays of light starting from the principal focus after passing through the lens undergo refraction. They bend and they go parallel to the principal axis. That means if the rays are coming parallel, after refraction, they will meet at the focus. Conversely, if the rays are starting from focus, after refraction, they will go parallel to the principal axis. Both the top and the bottom cases are true for any kind of convex lens. We should also remember every convex lens has two principal focus and two centers of curvature. Center of curvature is the point exactly behind the principal focus, which is double the distance from optical center. If you look into the diagram on the right hand side, bottom, this is a concave lens. If the rays of light are coming from infinity, after undergoing refraction, they will diverge. Concave lens is a diverging lens, so the rays of light are diverging. Now, when the rays of light are diverging, they are not going to meet. So, what we do is we pull them backwards and make them meet behind the lens, as you can see with broken lines, which ultimately gives us the formation of a virtual image at F2, which is the second principal focus of the concave lens. We should remember that concave lens is a diverging lens and hence it produces a virtual image. Conversely, the diagram on the top for the concave lens. If diverging rays are coming from infinity, after refraction through the concave lens, they will go parallel to the principal axis. So, we are supposed to remember both ways. In the bottom diagram, the rays are coming from infinity and they are divergent. They form a virtual image at F2. In the diagram at the top, diverging rays are incident on the concave lens. After refraction, they go parallel to the principal axis and they form a virtual image at F1. There is a difference in the position of F1 and F2 for convex lens and concave lens, as we can see here. For a convex lens, on the left hand side, we have F1 and on the right hand side, we have F2. For a concave lens, F1 is on the right hand side and F2 is on the left hand side. we should be careful while we are drawing diagrams, while we are drawing the ray diagrams. Every convex lens can be considered to be a combination of many prisms and a glass slab. If you look carefully in the diagram, this convex lens is a broken lens with a rectangular glass slab exactly in the center. If you see in the center, there is a rectangular glass slab, while just above this glass slab, there are broken pieces of a prism, and the topmost piece is a prism, as you can see. Similarly, just below this rectangular glass slab, there are inverted prism pieces, with the last piece being an inverted prism. So, when the rays of light are passing through these broken pieces of prism, they are bending towards the base of the prism. So, if I draw a ray of light from the first prism at the top, it will bend towards the base of the prism, and for the last prism at the bottom, which is an inverted prism, the ray of light will again bend towards the base. That will make both the rays of light converge at a point F, which is the principal focus of this convex lens. Hence, we should remember that a convex lens can be considered as a combination of many prisms and one glass slab. The rays of light passing through the prism will deviate towards the base. Likewise, I can draw all the rays which are bending towards the base of these respective prisms. Prism pieces, actually, these are not full prisms, they are pieces of the prism without the top. Similar thing can be explained for a concave lens. A concave lens is also a combination of many prisms and a glass slab. If you look at the center portion, the centerpiece is a glass slab, and at the top there are inverted prisms, while at the bottom there are erect prisms. So a ray of light that is coming from infinity into this first piece of broken prism will bend towards the base of the prism, and hence it will diverge. Similarly, a ray coming exactly at the bottom, hitting the piece of an erect prism or topless prism, will bend towards its base, and hence it will diverge. Consequently, the entire combination of these pieces of glass slab and the prism acts like a concave lens. Thus, convex lens and a concave lens both can be considered as a combination of many prisms and one glass slab, and the rays passing through these every part of the prism will always deviate towards its base, and hence they will give either a converging effect in the case of a convex lens or give a diverging effect in the case of a concave lens. We shall talk about how images are formed in convex lens. So, images formed by a convex lens. When we talk about images formed by a convex lens, we should know that there can be different positions of the object possible. So we consider first case when the rays are coming from infinity. For example, the rays coming from the sun. The sun rays are coming from infinity and they are parallel to the principal axis of this lens on the left hand side. We are discussing case 1 on the left hand side. So if we draw the rays coming from infinity and parallel to the principal axis, I consider two rays. This is the first ray. This is the second ray. After refraction, these rays are going to converge at a point F2 and thus form an image at F2. Remember, wherever the light rays meet, image is formed there. We can draw one more ray. 4 rays are enough to draw a diagram in any case. So one more ray and we get convergence of rays. Principal axis is a mandatory we are supposed to draw. We are supposed to write F1, F2 2f1, that is also known as C1, center of curvature, and 2f2, that is also known as C2, second center of curvature. Now, since the rays of light are actually meeting, they form a real image. Since it is a real image, it is inverted. Also, you can see that all the rays are meeting at a point, and hence we say that the image is diminished to a point, and it is formed at f2 on the other side of the lens. This case of the lens is used as a burning glass. It finds its use as a burning glass. If we use a convex lens, we hold it in sunlight in front of a paper, the paper would start burning because it will form a very highly diminished focused image of sun at a point that will make the paper burn. Coming to case 2, the rays are coming from infinity, but they are not parallel to the principal axis. They are oblique, as we can see. So again, we draw the lens. Remember, a lens should have a center line, middle line from which the rays are going to bend. So consider the rays that are coming from infinity, but they are coming oblique. After refraction, they meet at a point in the second focal plane. They are not going to meet at f2 because they are not parallel to the principal axis. Position, a case when they form an image at f2 is the one on the left hand side, that is case 1. Now, since the rays are coming obliquely, they will not form an image at f2. They form an image in the second focal plane somewhere below f2. Again, the rays of light are actually meeting and the image is formed on the right hand side. The image is real, it is inverted, it is highly diminished. There is a difference in case 1 and case 2. Case 1 says the image is diminished to a point because it is point-like. While case 2, the image is formed on the second focal plane, which is highly diminished and formed on the second focal plane on the other side of the lens. This case of convex lens finds a use in astronomical telescope. So, case 1, we should understand the difference. Case 1, image is formed at f2, real image, while case 2, image is not formed at f2, it is formed slightly below f2 in the second focal plane. There is a difference. We are supposed to remember the characteristics of the image formed as well as the of these two particular cases.